All right, section 5.3, we start into square roots. Just a reminder, when we're doing square roots, it'll be really handy to have out your perfect square chart, or you can look up the perfect squares online. It'd just be handy to see all those numbers in front of you when we're doing these. So square roots, which should be familiar to many of you. The radical sign or the square root symbol looks like this. And what this means is the positive square root of a number. Okay, so over here in the next line, you'd read that as the square root of n. So this would be the square root of n equals r. And the square root of n equals r if r squared equals n. So for example, the square root of 36 equals 6. So 6 squared equals 36. Okay, and n is called the radicand. Whatever is inside that square root symbol is called the radicand. That square root symbol is actually a radical. There's square roots, cube roots, fourth roots, and so on. In Algebra 1, you only cover square roots. In Algebra 2, right now, we're going to get into some more roots as this chapter goes on. But for right now, just square roots. So square roots are when you take the perfect squares and you kind of go backwards from squaring them. So like the square root of 36 is 6 because 6 squared is 36, or 6 times 6 is 36. So there are a couple properties. The product property says that if you have a square root of two numbers multiplied together, you can actually separate that into two square roots. So an example of this would be like if you have the square root of 125. Okay, 125 is really 25 times 5. Okay, so we can really break that apart into the square root of 25 times the square root of 5. Okay, so that's how the product property works. You can take a number, if it's two numbers multiplied together, you can actually split it apart into two radicals. And the whole reason we do this is because what is the square root of 5 or 25? It's 5. So this becomes 5 times square root 5. So that's why we do that. We can break it apart and we can get a perfect square times another number. Okay, the quotient rule says if you have a fraction inside of a square root, you can break it apart into two square roots. So for example, if we have the square root of 9 divided by 16. Okay, what this will equal is the square root of 9 over the square root of 16. Okay, and then we can actually reduce these because the square root of 9 is 3 and the square root of 16 is 4. So we end up getting 3 over 4. So we started with the square root of 9 over 16 and it reduced down to 3/4. So the product rule and the quotient property. And then we have a few examples to go through. So example 1, it says simplify the expression. So all of your perfect squares, I'm going to just list some over here. The perfect squares are like 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. So those are the numbers that we're going to kind of look at. Can 75 be divided by any of these numbers? So I'll start like, this is what I would think in my head. Can we divide 75 by 100? The answer is no. Can you divide it by 81? So take a calculator, 75 divided by 81 does not work. Then do 75 divided by 64. That also doesn't work. And you'll keep trying, and in the end, the one that does work is 75 can be divided by 25. And we're going to split this into what's called a perfect and a non-perfect. The perfect square is one of these numbers. The non-perfect square is the other number. So 75 can be broken apart into 25 times 75 divided by 25 is 3. Okay, so we get a perfect and a non-perfect. And the reason we want a perfect is because you can find the square root of the perfect. So what is the square root of 25? The square root of 25 is 5. So this becomes 5 times the square root of 3. And that's called simplifying the radical. So perfects and non-perfects. Okay, number 2. In number 2, you can think about doing this 2 ways. What I like to do is either combine the 2 radicals into 1, or you can try to break them apart. So let's start with 5. Can you divide 5 by any of these perfect squares over here? Okay, and the answer is no, you can't. Can you divide 12 by any perfect squares? 12 we can. 12 can be divided by 4. So it becomes 4 times 3. 12 is 4 times 3, so we break it apart into square root of 4 times square root of 3. The rest stays the same. So it's 3 times the square root of 5 times the square root of 4 times the square root of 3. Okay, and then this perfect, right here, the one in red, that's actually just 2. The square root of 4 is 2. So now we have 3 times the square root of 5 times 2 times the square root of 3. Okay, now this actually looks more confusing, but we can combine some things. What is 3 times 2? 6. Now what is 5 times 3? That would be 15. So this would end up being 6 times the square root of 15. So we broke apart the 12 into perfects and non-perfects. We simplified it and combined like terms. It actually is not exactly combined like terms, but we put together the radicals and we put together the non-radicals. Okay, number 3. Let's try to put some things together. What is 5 times 6? 30. Now in the square root, what is 2 times 8? You'd end up getting 2 times 8 is 16. So it's 30 times the square root of 16. Okay? And 16 just so happens to be one of our perfects. So what is the square root of 16? And the square root of 16 is 4. So this becomes 30 times 4, and 30 times 4 is 120. So that one worked out pretty nice. We could break it apart into, actually we combined it, and then the perfect square is 16, so we just went right into changing the square root of 16 into 4. There actually were no perfects and non-perfects there. Okay, number 4. We have a fraction inside of a radical. What we're going to try to do is break that apart. We can change it into a fraction with 2 radicals. So square root of 4 over square root of 25. What is the square root of 4? The square root of 4 is 2. What is the square root of 25? The square root of 25 is 5. So we end up with 2/5. We can't reduce that anymore, so this one is just 2/5. Moving on to number 5. Again, we have a fraction, so let's break it apart into 2 different radicals. Square root of 50 on top, and the bottom is the square root of 9. Okay. The square root of 50. Can we break that apart into perfects and non-perfects? 50 can be divided by 25. So the perfect would be 25. 25 times 2 is 50. So I'm going to break apart 50 into 25 and 2. The square root of 25 times the square root of 2. On the bottom, the square root of 9 is 3. So we end up with square root of 25 times the square root of 2 divided by 3. What is the square root of 25? 5. So it's 5 times the square root of 2 divided by 3. So we had a fraction inside of a radical. We split it apart into 2 different radicals. Then we broke apart the top into perfects and non-perfects. And on the bottom, the square root of 9 is just 3. And then we simplified the square root of 25 into 5. So it's 5 times square root of 2 divided by 3. Okay, the last type of problem you'll see is when we have a fraction, and when we break this apart into 2 radicals, like the square root of 3 divided by the square root of 5, they don't break apart and they don't simplify. So the issue with this one is that we can't have a radical in the denominator. So we can't have a square root or a radical in the denominator. So what we're going to do is turn it into a perfect. Okay, this is the tricky part. If we have a radical in the denominator, we have to turn it into a perfect. So we have the square root of 5 in the denominator, which is not okay. But can we change 5 into one of these perfects right here? So like, can we change 5 into 9 or 16 or 25? As you look at this, hopefully you thought, yeah, I can change 5 into 25. What do you have to multiply 5 by to get 25? You multiply it by 5. Now the trick is we have to do the square root of 5. Okay, and the rule is whatever you multiply on the bottom, you have to multiply that on the top. So on the top, the square root of 3 times the square root of 5 is the square root of 15. Okay, that's nothing special. But on the bottom, what is 5 times 5? 5 times 5 is 25, and we're taking the square root. So in the end, we have the square root of 15 over the square root of 25. What is the square root of 25? The square root of 25 is 5. So we no longer have a radical on the bottom. We change it from square root of 5 into 5. So square root of 15 over 5 is your final answer. And we can't reduce this. If you're thinking 15 over 5, can't they reduce? We can't because the top is in a radical and the bottom is not. So those do not go together. Okay, this is as simple as we can get. All right, we are going to stop here. We will pick up on the next part of the notes tomorrow in another short video.